Hello and welcome back for another triple physics lesson. This is lesson 2 in the seismic waves part of our course, and we're looking at the shadow zone. So our key words for today are mantle, outer core, refraction, P waves, and S waves. Now I've given you a do now activity which relates exactly back to lesson 1 of this series on seismic waves. So I need you to either look at your work from last time, maybe you need to write down these questions, or you can use Google if you wish. Okay, there's nothing wrong with using Google for these questions, just if you need to jog your memory. So I need you to click pause now and answer those 6 do now questions. Okay, our do now questions. Question 1, define the term longitudinal wave. Well, vibrations occur in the same direction as wave travel. Remember, in our longitudinal wave, they move back and forth. Question number 2, define the term transverse wave. Well, vibrations occur at right angles to the direction of travel. Remember, our transverse wave, shape of a snake, goes up and down. Number 3, state the 2 seismic waves that are longitudinal waves. We've got P waves and surface waves. Remember, P stands for primary. 4, order the 3 seismic waves from fastest to slowest. We've got P. P stands for primary, that makes sense. Then secondary, or S waves. And finally, surface waves. Question 5, name the only seismic wave that can travel through both solids and liquids. Those are our P waves. And finally, name the only seismic wave that can travel through the Earth. Those are surface waves. Kind of in the name, isn't it? Our objective today, our naughty words, is to explain how the shadow zone proves the 4-layer structure of the Earth. And we're going to have a 4-step learning journey for this. Okay, we're going to describe the shadow zone. We're going to compare the movement of S waves and P waves through the Earth. We'll explain the origin of the shadow zone, and we're going to explain how the shadow zone proves the 4-layer structure of the Earth. Now, before we delve into this being of a shadow zone, we're just going to have a quick recap on the structure of our Earth in case we've lost a bit of knowledge on that. So, first things first, our Earth has 4 layers to it. Okay, it's got the crust on the outside, think crust, slice of bread. We've then got the mantle. Remember the mantle I said is a semi-solid, a bit like ice cream, Nutella, peanut butter. It flows very slowly. We've then got our outer core and our inner core. Nice way of remembering this, the core of an apple is in the middle, so our cores must be right in the middle of the Earth. Our outer core is a liquid and our inner core is a solid. Now, our shadow zone is directly linked to this, okay, this structure of the Earth. I've got a similar diagram here. Now, our shadow zone, put simply, is an area of the Earth where S waves cannot be detected following an earthquake. Now, you'll notice on this diagram of the Earth in the centre, there's an area which is nice and bright and an area which is in shadow. Now, everywhere which is bright, you can see S waves following an earthquake, and everywhere where there's shadow, you cannot. So our first little mini review activity here, I want you to complete the sentence for me. Okay, the shadow zone is, and I want you to hit pause and complete that sentence. Our answers then is the shadow zone is an area of the Earth where S waves can't be detected following an earthquake. So we've got our basic understanding now. We're going to move on to begin to explain how this happens. And to do this, we're going to compare the movement of S waves and P waves through the Earth. Now, first thing, which perhaps is for us to start with, is working out which one of these diagrams shows S waves and which shows P waves. So I've got P waves here on the left. I'm going to start with P waves to explain. The first thing you'll notice about P waves is that waves are not stopped at all, are they? They start, we've got our earthquake at the tip of this here, and they go both through the mantle, they go through the liquid outer core, and they go through the solid outer core. So they pass through the whole Earth. Oh, and I've spelled whole wrong there. Apologies. That's our first thing. And the second thing you'll notice is that in the center of that Earth, they bend, don't they? Now, bend, the reason for this bend is that P waves refract, or they undergo refraction. And the reason for this is that we've got our liquid outer core, okay? Because it's a liquid, think a liquid's got to flow, so there must be little bits of space between those particles. We then go to our solid inner core. Well, if you think about a solid, for those not to fall, our particles must be very closely aligned. So that changes in density. And what this means is that our P waves actually slow down, okay? And because they hit at an angle, you'll notice in the center, only one of them goes straight through, and that's because it hits straight on. And when they hit at an angle, they bend. And you're going to learn a lot more about that in our future study of physics next year. But for this module, we just need to know P waves refract, and it's due to a change in density between the liquid and the solid. You will notice then, when we look at S waves, that S waves can only travel through the mantle. Okay, so they either move around our outer core or they absorb them through the mantle. And that's our key thing about secondary waves or S waves. Remember, we said they can't pass through liquids, which means they cannot get through that outer core in the center. Review 2 then. To compare the movement of S waves and P waves through the Earth, I need you to do a fill in the blanks activity. So you're looking at, if you're doing it on paper, writing out all the notes and highlighting, underlining. If you're doing it on your computer, just make it very clear for me, please, where the missing words are. And I'll lead you to click pause and complete this activity now. Okay, our answers then. P waves can travel through both solids and liquids. This means that they can pass through both the mantle, outer core, and inner core. As P waves pass from the mantle to the outer core, they undergo refraction. This is due to a change in density between the mediums. S waves can only travel through solids. This means that they can only pass through the mantle and are absorbed by the outer core. Just make sure you've got your answers in correctly then and you're able to mark. So if you need to click pause, please feel free. So far then on our learning journey, we have done numbers 1 and 2, haven't we? We've described what the shadow zone is, and we've compared the movement of S waves and P waves through the Earth. So step number 3 and 4, and it's going to move quite quick now, is we're going to explain the origin of the shadow zone and explain how the shadow zone proves the fore layer of the Earth. So our first thing, you probably have already noticed that the shadow zone diagram, which I showed you, looks very similar to the S-wave diagram that we've looked at. Okay, if you just want to have another look, we've got our S-wave diagram on the right and our shadow zone diagram. And it really is a simple explanation. The shadow zone is formed because S-waves cannot pass through the outer core. So we've got this really large area of shadow of S-waves because there's no S-waves there. And to top this up with how it proves the fore layer of the Earth then. And it proves two things. Now, the first thing that it must prove is that some part of our Earth, if S waves cannot get through, must be a liquid. Okay? So it doesn't necessarily prove which part is a liquid, but it proves that there must be some liquid in the inside of our Earth. But we assume, because of other sort of scientific discoveries, that they're talking about the outer core here. The second thing it proves is how big that outer core is, or how big that area of liquid is. Now, because our S waves can only move around our outer core, and everything else is held in shadow, it tells us how big the outer core is. If our shadow zone is very large, that means that not many waves are able to get around it, which means that we must have a really big outer core. If our shadow zone was very small, it means that our outer core is quite small, or our area of liquid is quite small. So scientists use this to calculate the size of the outer core. Review number 3 then, and we're looking at those final 2 points of the learning journey. I need you to complete those sentences. So what I need you to do, please click pause and answer those questions now. For review number 3, our answers then. The shadow zone is formed because S waves cannot pass through the outer core. Question 2, the shadow zone shows that a section of the Earth must be a liquid because S waves cannot pass all the way through. Number 3, the size of the shadow zone allows scientists to calculate the size of the outer core. So if you need to just do your marking, or obviously you may have slightly different sentences, that doesn't matter. As long as you've got the core knowledge there, I'm happy for you to give yourself a tick. Our last thing we are going to do then is we are going to do a multiple choice quiz on the whole of the shadow zone. Now, feel free, if you find that perhaps one is a bit difficult, you can click pause and think about it. You don't have to do it at the speed I'm going through them. If you're doing this on paper, just put question 1 and then the letter next to it. And these are all ABC questions. If you're doing these on your computer, just so I know which ones you did, can you please, just like I'm showing you, just change the color of the one you think is correct, okay? So that can be any color you want, as long as I can see it. Okay, question number 1. S waves are absorbed by the A, mantle, B, outer core, or C, inner core. Question number 2. As P waves move from the mantle to the outer core, they are A, refracted, B, reflected, or C, deflected. Question 3. Which of the following are not true of the mantle and outer core? A, they are different temperatures. B, they are different densities. Or C, they are the same material. Which of the following of those statements are not true of the mantle and outer core? Question number 4. Just remember at all times you can be pausing these guys. Question number 4. The shadow zone is A, an area of the Earth where no seismic waves are detected following an earthquake. B, an area of the Earth where no P waves are detected following an earthquake. Or C, an area of the Earth where no S waves are detected following an earthquake. So the shadow zone is A, B, or C. And our last question, question 5. Which of the following statements is not true? A, the shadow zone is used to identify the position of earthquakes. B, the shadow zone is used to prove that the outer core is a liquid. Or C, the shadow zone is used to calculate the size of the outer core. Which one of those statements is not true? Okay, we're going to go through some answers. So question number 1, S waves are absorbed by the B outer core. Remember, S waves can't go through a liquid. Mantles are solid, inner cores are solid, which means the outer core must be absorbing them. Question 2, as P waves moves from the mantle to the outer core, they are A, refracted. Okay, key word there. B, reflected. Think of a mirror. The waves don't bounce back at you. And C, deflected is correct in a sense, but it's not the correct scientific terminology. We are looking for refracted. Question number 3. Which of the following are not true of the mantle and outer core? Now, A is true. Okay, if you remember, the Earth gets hotter the closer we get to the inner core, so there must be a temperature difference. B, they are different densities. Well, we know they must be different densities because the mantle is a semi-solid and the outer core is a liquid, so their particles are going to be at different distances apart. So C, they are the same material. That is not true. And a nice way of thinking about this, the mantle is molten rock and the outer core is molten iron and nickel. So we got two different materials there. Question number 4. The shadow zone is C, an area of the Earth where no S waves are detected following an earthquake. Now we just think about why these are incorrect. A and B, they're incorrect for the same reason. P waves are detected in the shadow zone. Okay. And our final question, which of the following statements is not true? And it's A, the shadow zone is used to identify the position of earthquakes. So B and C are the way that it is used. It's used to prove that the outer core is a liquid. Remember, no S waves means there must be a liquid. And C, the shadow zone is used to calculate the size of the outer core. Think bigger shadow zone, bigger outer core. Thank you very much. We've got to the end of the lesson. I hope you have enjoyed, and I'll see you for lesson 3 on seismic waves. Thank you.